Let's proceed on solving the problem of simultaneous analysis of two compounds in a mixture by UV-Vis using Beers-Lampert. In this particular problem, we have an unknown solution that contains a mixture of both potassium permanganate and potassium dichromate. Normally, in a Beer's law problem, you only have one absorber, so you simply set up a Beer's law plot with standards of known concentration and measure their absorbance. Then you measure your one unknown, and using A equals the slope of that line times its concentration, solve for the concentration of your unknown. In this problem, we have two absorbers, and we know that the absorbance at any wavelength is a combination of both of those species. So in this problem, we had to actually collect standard data. So we set up our standards at 5, 10, 15, and 20 ppm, and then we measured the absorbance at two different wavelengths. This means that we have that standard data, the concentrations of the standards of the potassium dichromate, and the absorbances at two different wavelengths. And the same thing for the potassium permanganate. Since we have two absorbers at two different wavelengths, we're going to have 1, 2, 3, 4 Beer's law plots. 2 for the potassium dichromate, the absorbances at those two different wavelengths, and 2 for the potassium permanganates. So, if for the previous data, the total absorbance of the mixture was 1.13 at 420 nanometers and 1.34 at 560 nanometers, now instead of solving for just one of the concentrations, we can solve for the two of them simultaneously. Let's start by setting up what we know. At 420 nanometers, we know that the slope of the potassium dichromate is 0.087. And at 420, the slope potassium permanganate is 0.0113. This comes from these two plots. We have the slopes because we have the equation of the lines for all of those standard plots. At 420, the potassium dichromate absorbs 8 times stronger than the potassium permanganate. That means that the total absorbance, 420, is going to be the absorbance of the chromium plus the absorbance of the permanganate, or the total absorbance at 420 is going to be the slope, molar absorptivity times path length, the slope of the chromium times the concentration of the chromium, which I'll just note as C, plus the slope of the manganese times the concentration of the manganese. So capital M is equal to the concentration of the potassium permanganate, and capital C is equal to the concentration of the chromate sample. That's just to keep my algebra a little more obvious. If we substitute into this equation, that gives us one equation, which is 1.1298 equals 0.087 Cs plus 0.0113 Ms. We can do the same thing at 560 nanometers, where the slope of the chromium at 560 is 0.0203 from the data, and the slope of the manganese is equal to 0.0743. Again, these are just the slopes from the Beer's law plots at that wavelength. That means the total absorbance is the slope of the chromium times the concentration of the chromium plus the slope of the manganese times the concentration of the manganese, or 1.3378, the total absorbance at 560 is equal to 0.0203 C plus 0.0743 M. So we have now two equations and two unknowns, the concentration of the chromium and the concentration of the permanganates in the solution. If we start with this first one, we can write 1.1298 equals 0.087 C plus 0.0113 M, the first equation. We can actually solve this for what C is. If I go to just three significant figures here, now, let me back up a step. I can subtract both sides. So I'm just going to subtract the m's from both sides. And now to simplify, to go to three significant figures. When I divide both sides by 0.87, I can find that C is equal to 13 minus 0.130 M. Now I'm just going to substitute that back into this first equation, or this second equation here. So it's going to be, again, going to three significant figures. 1.34 equals 0.0203 times, and I'm going to substitute C in for that concentration. So it's going to be 13.0 minus 0.130 M's plus 0.0743 m's. Combining all my terms, so I'm going to multiply this by both of those. And now just combining my two m terms. So if I combine these two terms together, 0.002 m's minus 0.002 m's plus 0.0743 m's gives me 0.0717 m's. If I subtract the 0.2 from both sides, I get 0.0717 m is equal to 1.08. M is equal to 15 ppm. Now I just need to go back and substitute that back into my other equation, where 13.0 minus 1.30 oops, sorry. We'll slip the decimal point there. If I substitute that back in, 13.0 minus 1.30. So, from this, we could determine, if we go back to the original question, what is the concentration of the two species in the mixture? The concentration of the potassium permanganate works out to be 15 ppm. The concentration of the potassium dichromate works out to be 11 ppm.